So, good morning and good afternoon. So today is the second day of the forest fire management courses. So yesterday we introduced the course outline, right? That what we gonna do during 3 weeks. And yesterday we start to to review some of the important issues that related to forest fire, that we start from the global perspective and regional perspective on fire, that we talking about the cultural, the climate change, and yeah, something that related to forest fire, and then we start to get in more detail about the basic kind of forest fire that the forest fire managers should understand. And yesterday we start with some some basic information about the forest fire, fire nomenclatures, and fire shapes and fire type, right? And we and yesterday before we finish, we talking about the fire behaviors. So we look in some detail about the factors that influence on forest fire behaviors. So we talking about the fuels. So we talk about the climate and also the topography, that all three factors influence or uh, impact to the forest fire behaviors. So that what we talk. We have a lecture yesterday, right? So today, I will try to finish the basic information about forest fire science, and then fire ecology, not in more detail, but in general, that we can understand about the fire ecology in general. And after that, we will start talking about the fire cause and motivation of burning for burning, right? And also the last lecture of the day, I will talk about the forest fuel management, that which is very important things for forest fire management. Okay, let's start. Yesterday we talked until the factors of topography, right? That influence on forest fire behaviors. Today we will take a look on the forest fire behaviors. So the forest fire, what is the forest fire behaviors? The forest fire behaviors refers to how wildfire spread, intensity, and interacts with the vegetation. So the fire behaviors are influenced by the things that we talked yesterday, topography, weather, and fuel, right? So in terms of fire behaviors, uh, mostly we are very familiar with the quantitative fire behaviors. The quantitative fire behavior is, what is the quantitative fire behaviors? So the quantitative fire behavior is like the things that we can measure, we can number. The first thing is the rate of fire spread. Is that the spread at which fire moves forward? The second of fire behaviors in terms of quantitative is the flame length. So the flame length is the distance from the flame base to the tip of the flame. Normally we cannot directly measure, but we can use some equation to determine the flame length, and also the fire intensities. So the fire intensity is the amount of the flame that energy release, and also the fire intensity we cannot directly determine it. So we use some equation for fire intensity determination. So that was the quantitative fire behaviors. I will show you some equation later. But another fire behaviors that like qualitative fire behaviors. So the qualitative fire behavior describe the observed fire characteristics like crowning, spotting, torching, etc. So so this slide show you the quantitative fire behavior equation that developed by Byram since 1959. So this is very most common use for determination of fire line intensities and frame length. So this formula can use in many of forest ecosystem, but we have to acknowledge that this may not totally fit to some fire behaviors in tropical countries like in our region, because of course these fire behaviors developed from the temperate and boreal ecosystem in the northern region. But anyway, it's better than nothing. So you can try use that behavior. So sorry, intensity equation and framing equation to determine what about the five behaviors in your vegetation countries. For the qualitative five behaviors, as I said that it's like a descriptive uh, parameter that we do not measure in terms of number, but we just clarify or describe how fire behave in the environment. So most of the qualitative fire behaviors that we may know is about the creeping fire, running fire, fire whirl, spotting fire, or erratic fire behaviors. So those are some examples of qualitative fire behaviors. I may show you some photos of these qualitative fire behaviors. This one is sometimes we call running surface fire. That means fire spread very quickly, right? In contrast to these photos, this we call creeping fire. The fire that move very slow, right? Very opposite to the running surface fire, but still a surface fire. But maybe because of the difference in topography, in field properties, and in climate condition on that time, so that makes fire behave in different manners. Smoldering, smoldering, yeah. This is what you see from these photos, right? There's a lot of smoke. Sometimes it's the produce of smoke come from the field, the forest field that maybe not dry enough. You still have some moisture in the forest field that made produce a lot of smoke. And spotting fire. Spotting fire is very dangerous for many firefighters because they can, yeah, blow away out of the control area that made a new burning area and made difficulties for the firefighters. Torching out, torching out is something sometimes that the fire that move up into the canopies of the trees, in particular with the needle in particular with the pine or needle leaf trees, spruce, firs, etc. Crowning. Crowning is like the crown fire, but behave more uh, aggressive, like you see from these photos. uh. This is flare up by world. Yeah. Actually, I don't know if you can see from this video or not. Yeah, but this is what I took when I got the burning experiment in the Sweden farm in the northern of Thailand. So I got that experience in the Sweden farm. Yeah.
เปลวไฟถึงก็คือใช่เลยครับ
ประมาณนั้นโอ้ไปแปลงข้าวโพดเผาตอนบ่าย2:55ไอ้เจ้าของวิทยานี่
Okay, so that is some information about fire behavior that I think most of fire managers should understand somehow before they prepare to manage the fire. Okay, we will stop talking about the forest fire basic science from this one. Next, I would like to talk about a bit about the forest fire ecologies. Not in every aspect of forest fire ecology, but only in some aspect that may be important for the forest fire managers. So the first thing that I would like to talk is about we call the fire regime. File regime. The file regimes comprise of five components. The first one is file type. The second is file intensities. The third one is file frequencies. And the fourth is file season. And finally, is the burn or damage area. So both all of these factors or all these components, they they shape the forest ecosystem. And this file regime will affect the species survival and also species composition and adaptation in the ecosystem. So this slide represented for the global file regime status. So based on the ecological region assessment, this research done by Srisky since 2007. So it evaluates the current condition and the trend of the file regime worldwide. And the map, this map categorized the global land area by the condition of the file regime. The file regime in terms of the file frequencies, file intensities, file size, and seasonalities across the ecological region. So this map underscores the widespread degradation of natural file regime globally, stressing the importance of restoring file adapted landscape, adapting file management strategies, and monitoring climate file. So what do you see from this mapped colors? You see that over the half of the world, has degraded file regime. So this suggests a substantial alteration in natural file pattern, often due to the human activities and land use change. And only not more than 25% of the region maintain intact or stable file regimes. The yellow area from the map means it is very degraded or declining that we require the urgent attention due to ecological vulnerabilities and disruption. So this was done since 2007. Just want to show you how important and how far influence in the landscape all of the world, and how ecosystem intact or degraded as the result of the fire. But this I already mentioned, so I will skip to this. So the fire regime, as I mentioned, that refer to 5 components, right? Frequency, which is very important, and I myself, I think this is the most important things for fire regimes. Type of fire, seasonalities, intensities, and severities. So these elements define how fire behave naturally in the ecosystem, and change any fire regime component will affect the ecological process and component, including the plant. The fire can promote or suppress a certain plant species, affecting vegetation structure and diversities. The soil. Fire alter the soil chemistry, in particular, compaction, erosion potential, that means the soil physical properties. For animals, fire affects the habitat availabilities, food resources, and survival of fauna. For nutrients, fire can release or deplete the key nutrients like nitrogen and phosphorus. For water, fire influence the watershed hydrology and water quality, water supply, and also some sediment and runoff from the watershed area. So all the change in the fire regime, especially for fire frequency, timings, and intensities, can profoundly disrupt the ecological balance. So managing the fire regime with historical or ecological appropriate lengths is essential for biodiversity conservation, soil health, and climate resilience. So fire regime is very important. And remember that the most important thing for fire regime is the fire frequencies. So next comes to the the diagram that I always talk for this one. I talk every time to my student in Thailand, or whenever I give talk to any person I have chance. So what I'm talking is about the ecological rotation in relation to fire frequency and nutrient capital, which is reflect to the importance of the fire frequency to the ecosystem health. So this diagram illustrates how the 5 frequencies that influence the ecological rotation and nutrient capital over the time. So it highlights the balance needed between the fire use and ecological sustainability. So from this illustration, the y-axis represented for site nutrient capital. So, so the x-axis represented for timing, that show the progression of time with multiple fire events occurring. So what I would like to show and explain to you by using this illustration is that there are 3 of fire regimes compared in this illustration. So the first one, as you see now, I call the infrequent burning regimes. This is in the yellow solid line, like this. So this this fire occurs at the interval that allow the nutrient and biomass recovery. So this burning will result in site nutrient capital remain relatively stable, as you see from the dash line of the blue dot line. So the so for this burning interval, fire will help to recycle the nutrient efficiency, support the ecological resilience and biodiversity. This is what we would like all of the ecosystem to have. But in fact, what we have mostly in the ecosystem in the world now is this. So for this, the I call too frequent fire regime in the yellow dot dash line. So this frequent fire prevent the full recovery of site nutrient between burn, and this results in the progressive decline in nutrient capital, ecosystem degradation over the time, and lower productivities and resilience. So this what most of the ecosystem in the world are facing now, that we have got too much or repeated burning that will result the the decline the decline of the ecosystem health. By contrast, some ecosystem I call the long-term fire suppression in the red line. So this scenario is a complete absence of the fire over a long period. So this will result in, of course, in initial nutrient accumulation will increase, of course. But over time, this situation or these scenarios will lead to fuel accumulation, high risk of catastrophic fire, and potential for large nutrient losses when fire eventually occurs. So this is the three scenarios that happens in our forest ecosystem right now. So the message from this diagram is a moderate and well-managed fire regime will promote the healthy ecological cycles and maintain nutrient balance, while both excessive fire and complete fire suppression lead to long-term ecosystem degradation. So this is very important point for the fire ecologies that I would like to stress and mention about the impact or importance of the fire frequency to the ecosystem health. Okay, next we will talk about the ecological role of fire in different forest biomes. In this slide, we look at how ecosystems across the globe can be classified based on their relationship with fire, which is largely influenced by climate, topography, vegetation, and soil characteristics. So these factors together shape what we call the fire regime of a particular area. So based on the fire regime characteristics, the forest ecologies are broadly grouped into three categories. The first one we call fire-dependent ecosystem. So these are ecosystems that rely on regular fire to maintain ecological balance and biodiversity. The examples of this fire-dependent ecosystem include the boreal forest, eucalyptus savannas, some temperate Mediterranean forests. So in this region, fire help to clear undergrowth, regenerate fire adapted species, and cycle the nutrients. The second we call the fire-sensitive ecosystem. So this in contrast to fire-dependent ecosystem, because some ecosystems are highly vulnerable to fire. These include the tropical evergreen forest, where the fire can cause significant damage to the biodiversity and ecosystem function due to the absence of evolutionary fire adaptations. The third one we call fire independent or fire free ecosystem. So this area rarely experience fire naturally, such as in the desert and the tundra. So understanding this classification will help into applying appropriate fire management strategy using fire where it is ecological benefit and preventing or suppressing it where it is harmful. So this is the classification of fire ecology, which is based on global fire regimes. So this is just to show you some photos of the fire independent ecosystem like in tundra, right, and desert. And most of our forest ecosystem in the world mainly is fire dependent ecosystem. So let's take a look more detail or look closer about the fire independent ecosystem. So this ecosystem is where fire play critical role in shaping the structure, composition, and ecological process, as I mentioned earlier. So this ecosystem, in this system, fire is not a disturbance, but rather is an essential natural process. So over the time, many plants and animals have evolved in a specific adaptation that allow them to survive and even benefit from fire. For example, some trees have a thick bark to protect themselves from heat, while others require fire to release their seeds. In fire-dependent landscapes, the vegetation often contributes to the fire spread. So these are what we call fire-prone or flammable system. So this may sound negative, right? But in fact, this system these systems are adapted to burn at specific interval, intensities, and seasons. So we refer to this ecosystem as either fire adapted or fire maintained, meaning they depend on regular fire cycle to stay healthy and functional. So without fire, some species may disappear, invasive species may take over, or the fuel load may accumulate to dangerous level. However, if the fire regime change too drastically, for instance, if fire become too frequent or repeated burning, too intense, or even complete suppressed, it can push the system beyond their natural variabilities. When this happens, the ecosystem balance is disrupted, leading to biodiversity loss, soil degradation, and long-term ecological damage. This is some adaptation of three species in fire-dependent ecosystem from Thailand. I will talk in more detail about this one later. You see this, some bark, very thick bark, and sprouting capacities, seed retention, hard seed coat, for example, and salutinous coat, etc. So for the fire-dependent ecosystem, the fire regime vary very greatly, range from frequent low intensity to mixed severity fire until high severities. But the main message for the fire-dependent ecosystem is that ecosystem need to burn under the appropriate fire regime, in particular the fire frequency. So there is some photos from Thailand. We call dry dipterocarp forest or deciduous dipterocarp forest. The abbreviation is DDF, right? So the dry dipterocarp forest is the fire-dependent ecosystem that rely on fire for ecological balance. But however, the challenge arises when the fire is either too frequent or excluded entirely. Right now, we have a lot of too much burning or repeated burning that can degrade the ecosystem and reduce the biodiversity and soil health. So but in some places, there are totally fire exclusion. There is too much burning versus too much fire exclusion. Now, we have a very challenge for dry dipterocarp forest in Thailand, also in Laos, Cambodia, and Myanmar. We have faced this kind of problem too, mostly in too much burning because of the policies. Just to show you some impression of the dry dipterocarp forest, what it look like. Yeah, and you see that the fire in dry dipterocarp forest when it burn, it seems like everything gone, all the tree dry, but in fact, when the rain come again, so everything will be clean again, green again. But for fire sensitive ecosystem, the fire sensitive ecosystem are those where species have little or no adaptation to fire. Even low intensity fire can cause a high mortalities among plant and animal. So this ecosystem typically have vegetation that made of non-flammable species, which naturally resist to burning. However, when forests become fragmented, the condition change. So the microenvironment at the edge become more vulnerable. The field characteristics change. Ignition risk increases, and fire become more frequent and widespread. So over time, the fire tolerant species may invade, and the original species, those that cannot handle it, are lost. So as a result, the ecosystem gradually shifts toward the fire-prone vegetation structure, changing its ecological identities. We also have another sub ecosystem we call fire influence ecosystem. The fire influence ecosystem lies between fire dependent and fire sensitive. So these systems are generally sensitive to fire, but they still contain some species that can tolerate to or survive under the fire environment. So this, sorry, the role of fire here is less understood and often overlooked. So however, with the climate change, drought, and fire disturbance may change or may shift this ecosystem, making their response to fire more important in the future. Next, I would like to show you some important things of plant species that how they survive under the fire environment. So we call the adaptation threat of the plant. So the adaptation to fire for the trees and vegetation largely depend on some few key traits. The first, the vulnerabilities vary by tree species, maturities, and the seasonalities. For example, during the flowering or seed formation. Trees have a low carbohydrate reserve and are more sensitive to fire. The second, which is very easy to see or to distinguish or to determine which species is fire tolerant or fire dependent or not is the bark thickness. So the bark thickness play a critical role in fire resistance for trees. A thicker bark insulate the tree from the heat. So many research show that the bark thickness of around 1 to 1.3 centimeters can protect a plant species tissues. Can protect plant tissues from lethal temperatures. So bark thickness also change. It's thinner when they are young and become thickened when they reach the maturities. And again, then the bark will decline again as the tree age or getting old. So this graphs or chart, I will show you the thermal inertia, which is very important for the related to the bark. The thermal inertia. What is the thermal inertia? The thermal inertia refers to the delay response of internal tissues, like the cambium layer of tree, to change in surface temperature during the fire event. So in this graph, we compare the surface temperature and cambium temperature over the time. So the black line, as you can see now, the black line represented the surface temperature, which rise rapidly and peak sharply, reaching temperature close up to 1000 degrees Celsius. So this spike reflects the intense heat at the bark surface, during the fire exposures. Meanwhile, the red line shows the cambium temperatures. So this unlike the surface, it heats up more slowly and peak later at as much lower maximum, around not more than 30 to 40 degrees Celsius. So this lag is what we call thermal inertia. The thermal inertia can protect the inner tissues from immediate damage. But if the fire duration is long, the accumulated heat may still be lethal to the cambium. So this concept is crucial for understanding tree mortalities after the fire, especially in relation to bark thickness and fire residence time. So overall, this delay between surface and cambium heating is very key factor for post-fire tree survival. What is the threat of the species for staying or surviving under the fire environment? So the protected bud is another threat that plant develop to survive under the fire. The protected buds are crucial. So this bud located deep within the plant tissues or underground, a safeguard for the meristem, the growing point against the heat damage. So some species may rely on fire-stimulated germination of seed. So fire break the seed dormancy through the heat of smoke, especially in species with hard seed coat or seed buried in the soil. Also, some species we call fire-stimulated sprouting. So that means after the fire, even the main stem destroyed, so tree can resprout back again after the fire. This is a very special characteristics of tree that can survive in the fire environment. Some species show the seed retention and fire stimulated seed dispersal. So this plant keep the seed on the tree and release them only after the fire, often through the specialized structure like serotinous cone that you might know, right? Also, some species in tropical countries like in Thailand, we have some deciduous dipterocarp species that most of the seed uh, rely on uh, on a fire that fire stimulate the seed dispersal. That means the seed of the some dipterocarp species will fall down after the fire. So this falling down after the fire will ensure the seed fall onto the nutrient-rich ash bed with better hard light and space for germination. Next, fire also trigger the flowering, especially in monocotyledons such as grass, lilies, irises, orchids, etc. So fire can act as the cue for this plant to reproduce quickly after the disturbance. So those are some uh, adaptation traits of plant species that can survive under the fire environment. So I want to, sorry. So this one, what is the one? So this, I want to show you what about the Thailand forest ecosystem in terms of the five ecologies. So of course we divided our our ecosystem into five dependent ecosystem groups and five sensitive ecosystem groups. The yellow one, those are five dependent ecosystem groups like dry deciduous forest or dry dipterocarp forest, which I just mentioned to you that there are some deciduous dipterocarp species dominant in that area. Also, the mixed deciduous forest where we have teak. You might know teak. Teak is the most valuable timber in our countries. So teak mostly dominant or grows in mixed deciduous forest and pine forest. So those three ecosystems are fire dependent ecosystem. Another group is fire sensitive ecosystem that mostly are evergreen, either the evergreen, moist evergreen, dry evergreen, hill evergreen or mountain forest, peat swamp forest, mangrove, and beech forest. So those are fire sensitive ecosystem. But what I would like to mention is that for some fire sensitive ecosystem like dry evergreen, hill evergreen, and swamp forest, so so those influence right now they are influenced by fire, in, by fire, which fire happen more than in the past. So this fire make this ecosystem prone to repeated fire in the future and might change the structure and composition of the forest ecosystem for this ecosystem in the future. This I already mentioned to you. And again, this one I show you already, right? Another things that related to burning, that related to plant species that I'm just would like to talk to you again is about the species selection and invasion. So in the fire-prone environment, a certain plant species known we know as the pyrophytic plant. The pyrophytic plants have evolved traits that help them to survive or even thrive after fire. So these include what I already told you, thick bark that protect inner tissues, the ability to copy or resprout from the stem, seed thread that promote the survival and regeneration, including heat-resistant seed coat and effective dispersal strategies after the fire. And so after the fire, the landscape normally is open, right? Open. And this often recolonized by those xylophytic species. The xylophytic species that is plant that adapt to dry or fire-affected conditions. So these species are quick established in the burn area, shaping the structure and recovery of the post-fire ecosystem. So after the fire, most annual and perennial pyrophytic grass, especially those in Poaceae families, are often favored and rapidly recolonize the burn area. So among them, you might know the Imperata species. This is a very aggressive invaders. In Asia, we have Imperata cylindica in Asia, and in the tropical America, you might have the Imperata brasiliensis, right? So these grass dominate the fire-degraded tropical forest. So their spread will alter the environment, especially the forest field condition, that changing the type of the structure, arrangement of field, and everything on the ground. So these gases will create a positive feedback loop known as the glass fire cycle that what I will show you later. So this just to show you some impression of the glass that dominate in the forest area and sometimes become the grassland. So this is the loop of glass fire cycle. So this diagram will illustrate how fire can create a positive feedback loop that increase their flammability and promote a drier condition over the time. So it is often begin with the human disturbance like timber harvesting, agricultural expansion, or fragmentation of the forest, which increase the ignition sources in the fire-sensitive forest ecosystem. Once fire occurs, it disrupts the native vegetation and alters field structures, making the landscape more favorable. In many cases, non-native drought-tolerant grasses are introduced, either accidentally or intentionally, which further increase the fuel availabilities. As the fire continues, the system shifts toward the grassland or savanna, and both flammabilities and microclimate feedbacks amplify the risk of future fire. So this cycle degraded the forest ecosystem and make recovery increasingly difficult, locking the landscape into the fire-prone state. So those are like a glass fire cycle. The last slide for the review introduction of forest fire science that you should understand is here. This is the last slide for you in the introduction. So this one, what is this? What I would like to talk to you for this slide is this is the diagram that highlight how the natural fire disturbance shape the ecosystem and how different management actions influence a key fire variable. In particular, frequency, intensity, and burn area. So these are like the 3 dimension. At the center of the axis, the center is a natural variation of disturbance represented by the blue zone color. So when fire occurs within this zone, the balancing between fire frequency, intensities, and burn area, it tends to maintain ecosystem function. So let's take a look at the label part. A, A, A here is here. The A shows an increase in fire frequency, which may occur from excessive ignition. In contrast, the C represented the expansion in burn area, possibly due to the lack of fire break or because of the drought. The D, what's it D? D is here. Yeah. D illustrate too much fire suppression, which reduce the fire frequency and the area temporarily, but may lead to the fuel accumulation and more intense the future fire. So those management practice, you see that they are not in the blue cycles, in the blue circle. That means those management either by A, C, or D. So those management out of the national disturbance of variabilities. What about E? The E make a zone close to the original, where fire regime are minimal or entirely suppressed. This might reduce the disturbance dependent process like nutrient cycling or regeneration. So when the management like E present in the blue zone, that means we try to manage in the way that compromise for the natural disturbance of the fire in this blue zone. So the goals of ecosystem management is to maintain the disturbance regime within the natural range of variation. That means within this blue zone, supporting the resilience and biodiversity without allowing them to become too extreme or absent. This is just the concept that I want to mention to you that whenever we manage the forest fire, so please thinking about the national disturbance, like fire, because fire sometimes is good, sometimes it's bad, right? Too much fire is not good, but too much fire suppression is not also good too. So we have to balance the management to be inside this the blue cycles. That's what I were to mention and end for this slide, end for this presentation for for the introduction. So those are the things that I think that it's very important for you to 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 review again, that I already reviewed to you for your understanding more or less. Yeah. From now on, I would like to talking about the cause and the motivation of burning. Where is my slide? Cause and motivation is here. Okay. I have to share cause and motivation. Where the cause and motivation here. I think can you see the slide? Can you see the new slide? My new slide? The causes and driver and motivation of fire. So what we would like to talk to you right now is that we want to see what is the cause, driver, and motivation of forest fire. Of course, different culture, different region, different countries may have different cause and motivation in burning. I would confess on that. Yeah. But at least I think what I would like to show you now is something that happened in South Asia countries, South Asia region, in particular in Thailand, Laos, Cambodia, Myanmar, and Vietnam. Okay, what is this? This is I would like to mention to talk about the perspective. I I I I prepared this slide myself. I'm thinking about the burning perspective. So these triangles illustrate the the three key perspectives that influence how fire and burning are understood and managed in the landscape. So at the top left, or the yellow arrow, these are the government and citizen perspective. So this perspective, or this yellow from this yellow arrow, represent that the problem perspective. So that means the government and the general people or general publics often see the burning primarily as the threat that links to air pollution, public health, and deforestation. So their perspective focusing on controlling or banning the burning due to its negative impact. That is the first perspective from the government and the public section that you can see from the yellow arrows. What about in the top right, the blue arrow? The blue arrow represented for the villagers, the farmers. So this is the tools perspective. For the local villagers and farmers, especially those practicing traditional agriculture, fire is a tool that used for land preparation, for weed control, and sometimes for promotion of non-timber forest products like mushroom. So their knowledge of when and how to burn is often based on experience passed down to the generation. So this is what is the perspective from the villager and the farmers. For me and for you, maybe at the bottom, the green arrow, the researcher perspective. So what we look at the fire in this perspective we look at this is environmental factors perspective. So researchers like us approach the burning from an analytical standpoint, that studying the effects of fire on ecosystem, the fire behavior, fuel load dynamics, and long-term ecological impacts. So they aim to understand both the risk and the potential ecological role of fire. So at the center of this illustration is the red triangle. So this is a point of balance or tension where all three perspectives intersect. So the effective fire management must integrate all three viewpoints to develop the solution that are ecologically sound, socially acceptable, and practically feasible. So these are some perspectives on of fire based on different perspective. I may stop for 15 minutes because I feel tired now. So let's take a break for 15 minutes. And then after come back for 15 minutes, that means in yeah, quarter past 3, right? Bangkok time. In 15 minutes, we will come back and we will continue talking about the the burning motivation in burning again. So let's take a break for 15 minutes, please. Okay, see you. Motivation. Okay. Let's talk about the burning motivation in Mekong sub-region, also in Thailand, yeah, and also I think in many countries, maybe. So these are the same motivation that influence on burning. So in Mekong sub-region, in particular in countries like Cambodia, Laos, Myanmar, Vietnam, and Thailand, we call MVT. Fire is shaped by multiple motivation, so that interact like a moving gears. So what is the burning motivation in this region? We can classify into 5 motivation. The cultural motivation, that many communities use fire as a part of traditional use practice. For example, rotational farming, ceremonial burning, and stimulating growth of forest products like mushroom or some edible plants. So this cultural use of fire is embedded in local knowledge and identities. So the next motivation is the economic motivation. So the economic motivation also used as a low-cost tool for agriculture, especially to clear land, control weeds, and stimulate crops like maize or upland rice. So in forested area, fire may increase the productivities of high-value non-timber forest products. The ecological motivation. So in some ecosystem, fire help to maintain the ecosystem balance. For example, the controlled burning may reduce the invasive species, recycle nutrients, or maintain open habitat for some wildlife. The policy motivation. The government rules and land management policies can either encourage or restrict fire use. In some areas, there's a support from community-managed fire regimes. In others, there are strict ban or criminalization of burning, even when it's traditionally used. Finally, the political motivation. The political influence often override the technical or cultural consideration. So decisions about fire are sometimes driven by national image, public pressures, or media coverage, particularly during the trans-Boundary health crisis. So this political force can reshape or disrupt local fire governance. So those are the main motivation of burning in this region, and also I think those are in many parts of the world too. So going in more detail for the burning motivation in terms of the cultural motivation. For cultural motivation, for youth in the rural and forest communities is strongly shaped by culture. It is not just a tool, but it is a tradition. The first, community rely on fire for quick access to wild food like mushroom, edible plants, and for clearing the grassland for grazing. In upland areas, the ethnic groups use the fire to prepare the land for shifting cultivation that sometimes we call slash and burn. The second, fire is often seen as a normal and even helpful. For example, restoring the visibility of non-timber forest products in the mixed forest. The third, many communities don't have a clear land right. Without ownership, there's little motivation to care for the protect forest, making short-term burning more common. The fourth, social pressure matters. If one family burn and benefit, others may feel the need to follow. This is especially changing as traditional value shift due to aging population or migration. Finally, there's a lack of communication, scientific knowledge, rarely reach communities in practical ways, and they often have a space to learn about alternatives. In a short conclusion for cultural motivation, to reduce the harmful burning, we must understand this cultural motivation and work alongside the local knowledge, not ignore it. So this is the message that I would like to send to you for the cultural motivation of learning. What about the economic motivation in terms of economic motivation? So economic is one of the strongest driver of the fire use in many regions of the world. The first, fire is cheap and fast. So the farmer use it to reduce the labor and machinery cost when clearing the land, especially in remote or steep area where the other options are limited. The second, annual crops like corn, cassava, and soybean require land to be cleared every year. So burning is the fastest way to prepare for plantings. The third, the market system adds pressure. For example, animal feed factory drive demand for monocrops like corn. So high price push the farmer to expand quickly, and fire is the quickest tool. The fourth, many smallholders face the high debt and unstable income. So with limited resources, there is little investment in fuel management or alternatives. Finally, the government incentives are missing. Without access to carbon market or financial support for non-burning methods, farmers stick with what's cheap and available. So in summary, for the economic motivation, fire remain the go-to method, not because it's the best, but because it's the most economically valuable for vulnerable farmers. For the policy motivation, the policy framework can unintentionally contribute to the fire problems when they lack flexibility or local sensitivities. The first, the zero burning policy strictly prohibits any burning regardless of context. So this forced some villages to burn in secret, often without control, because the lack of viable alternative. The second, the unclear or restricted land tenure weakness weaken the community incentive. If community have no right to manage or benefit from the forest resource, they may less motivated to prevent the fire. The third, the budget often prioritizes firefighting, not prevention. So this little support for proactive fuel management or for community-driven control burning. The fourth, centralization of the fire management means that most decisions come from the top. So this disconnect policy from local realities and leave little space for community engagement. Lastly, the broader economic development policy, such as promoting cash crop or building the infrastructure, can lead to the forest encroachment, if not paired with the environmental safeguard. For the ecological motivation, the fire is not always destructive. In many ecosystems, it plays an essential ecological role. As I always mention, the first, nearly half of Thailand forests, especially in dry deciduous forest, mixed deciduous forest, and pine forest, are fire adapted ecosystem or fire dependent ecosystem that fire help with natural regeneration, composting, and maintaining structure and biodiversities. The second, in the forest management system, especially in teak plantation, Fire is used for site preparation, weed control, and pest reduction, in particular tick beetle borers. The third, in protected area, fire helps to manage the grassland and prevent the tree encroachment, so control burning used in several wildlife sanctuaries, like in Pu Kiao, Hoi Ka Keng, wildlife sanctuaries, that to maintain the habitat for wildlife. So in summary, the ecological motivation show us that fire can be a tool in case that used with the right frequency, in the right context, and with the clear objectives. So these are some motivation that I try to analyze based on our experience from mainland Southeast Asian countries. So I will skip this slide because this is I just want to show what is the cause of burning, that you can see that there are natural and human-induced cause of fire. So I will not go in detail for this, but in summary, I just want to inform that the forest burning is very complex. In a complex interaction of the social, ecological, economics, and political driver. So each require a different response in the fire management strategies. Moreover, the forest burning is driven by several interlinked factors. Of course, the politics that we already mentioned, that politics can shape and how how the land is governed and how burning is controlled. The climate change so make the environment more fire prone. A longer dry spell and higher temperature increase both frequency and intensify the fire. Agricultural values and non-timber forest product value is there are also the case for stimulated burning motivation. For the case of agricultural value, in this case, refer to the price of agricultural commodities. So when the price for crops like maize or cassava are higher, the farmers are more likely to burn forest area to expand the cultivation quickly and at a low cost. For non-timber forest product value, such as mushroom, edible plants, eggplant, red ants, for example, bamboos. So those non-timber forest products also drive the burning. So fire can make these products easier to harvest, giving people short-term economic gains. So all these factors together stimulate the burning behavior and make fire recurring tools in both local economy and land management. So this I also want to skip on that because this is the cause of fire that I just mentioned in the previous slides. So this just to show you some causes of fire in our countries, in Thailand. But next is more important because this will be summarize the cause of forest fire in Thailand during 1998 until 2009 on the cause of burning in Thailand. So what you can see from here, you see that the leading cause that accounting for nearly 37% is burning for non-timber forest product, especially mushroom, edible plants, bamboo shoot, etc. So this is the most important cause of burning in our country, even nowadays. Hunting follow very closely. It took around 20%. It took around 20% that people burn the forest for hunting. Agricultural debris burning. make up about 16%, reflecting the land clearing and residue management practice. Meanwhile, the conflict, whether over the land rights or policy, contribute to about 4.5%, while the illegal logging accounting for smaller portion, at about 2.3%. But others minor causes include the cattle grazing, accident, and tourist activities. That about not much in percent. So what is this? So here is a short presentation script for the infographic that links to the source of PM2.5 in the year 2023. Why we bring the PM2.5 to show for this case? Because the PM2.5 are very close related to forest fire. So in 2023, the Thailand record a total of 172,000 fire hotspots nationwide. Of these, nearly 70% occur within the forest area, particularly in protected and reserved forests. Focusing in the north of the countries. So the northern region stand out with the highest concentration of hotspots, covering 17 provinces, and contribute significantly to the PM2.5 emissions. Within this region, around 86% of the hotspots were in the forest area. So the main cause of the PM2.5 in the northern region comes from the forest fire, the crop residue, and field burnings. And of course, some PM2.5 comes from transboundary haze and smoke pollution from neighboring countries. But in the south, in the pink layer, in the south, peat swamp forest fire and transboundary haze are the major contribution of PM2.5. So this data clearly show that the PM2.5 is not only a forest fire issue, but a complex challenge involving land use, livelihood, and regional pollution sources that we have to cope with. So just to show you some example of cause of forest fire in many parts of Thailand. So what about in your countries? What about the cause of forest fire? What about the motivation of fire in your countries? So we will talk a little bit later. So this is just to show you some places in the northern of the countries where the local or ethnic groups, they have sweetened farm, they have sometimes like a shifting cultivation. So in this case, they plant corn. They plant corn. Before they plant it, they do slash and burning, and then plant the corn for some years and moving around and leave the area for fallow period for 5 or 6 years. And this is a very interesting thing in Thailand. Many people say that these are the most highest cause of forest fire in Thailand. So this is the mushroom we call puff mushroom, or in Thailand we call hed thaw. So this is very high value of mushroom that most of them collected in post-burn forest area. So I have some interesting data showing to you. So this is showing the economic value of puff mushroom, which is related to burning. So we did these studies in Wat Chan pine forest in Chiang Mai province. It's around 6 years ago. Yeah. So we focus mainly on head top, which often emerge in abundance post-fire. So using the community-based approaches, the local villagers serve as also our citizen scientists. We collect the data over the month from May until July in 2019. So the result of the mushroom economics is very interesting. As you can see from this slide, the total economic value is about 14 million baht. 14, 114 million baht that was generated in just 1 month. In just 1 month. And the market price range from 40 to 200 baht per liter, with the peak harvested with hitting the 14,000 liters in only one single day. So this, in this case, created a theory that post-fire ecosystem can provide a short-term but significant economic benefit to local communities. In this case, for the mushroom, it emphasized the importance of integrating ecological knowledge with local livelihood in fire management policy. So this is very challenge issues in Thailand now today, because most of the local people, they need to collect, they need to have more mushroom, and mushroom must be happen in the burned area. That is their belief. That's why some years the forests are burned a lot because of the non-timber forest product for mushroom in this case. But not only the mushroom that the local people they use fire for harvesting the mushroom. Also for some edible plants, other edible plants. In this case, the million tar service is a very good taste for this plants. Also comes from burning as well. Some years ago, yeah, when we still have the resin tapping harvesting, so some people they burn the pine forest for resin tapping, but now it rarely happen. It rarely happen in Thailand nowadays, because we banned for burning in the pine forest for resin tapping. This is just to show you the case of burning in different parts of the countries. What I show you already is about the cause of fire, mainly in the northern of the countries. But what is I am showing to you now is the cause of burning in the southern of the countries, in the peat swamp forest, in the southern of the countries. So this slide represents the major cause of burning in Khon Kreng peat forest, based on the data from Department of National Park, Wildlife and Conservation. So there we see that the dominant cause of the fire here is come from deforestation, that accounting for more than 67%. So this reflects the high pressure to convert the peatland into agricultural land, particularly in oil palm plantation. So other notable costs include agricultural residue burning, non-timber forest products, etc., but not much compared to burning for deforestation. So this is different, right? Even in one country, there is different cause of fire. So this is what they have done in peat swamp forest. They cut, sometimes they burn to claim the land. Yeah. Okay, that is some motivation cause and motivation of burning in case of Thailand. In case of Thailand. So what we would like to talk to you before I'm going for the next thing is that now I would like to give you some assignment because uh, the assignment, yes, I think you can you see the assignment now? Yes, the assignment because we have already finished. I think the most one part, the one section of the lecture. So what is the assignment that I want you to do? So the assignments uh, it can be either by review, analyze, or synthesize. eh? So what I would like you to do, this is the first assignment because I just show you some examples of the burning cause and motivation in case of Thailand already. So what about the forest fire situation in your countries? What about the big issue in your country that related to burning? For example, in Thailand now, the big issue for burning is related to PM 2.5, related to non-timber forest products, burning like burning for mushroom. So this is our big issue in Thailand. What about in your countries? What about the cause of burning and the driver and motivation of burning in your countries? And what about the forest fire statistics in terms of burning area, hotspots, or etc. that related to forest fire? What about your situation? So this is the first assignment for you. What you should do is that so the report, as I said that the report you can do like in the review, analyze, or synthesize. And the context in your report can be with figures, charts, photos, and citation. And the citation which very important, the citation. Right? And when you finish, you should submit this file in the PDF format and upload to the Google Drive. Oh, sorry, not Google Drive. Sorry, in the Google form. Yeah. So submit in the PDF format and send report to the Google form. Follow this link. So please copy this link. So when you finish your report or your assignment that I just mentioned to you, so submit the report to this Google form. And for the first deadline that I just mentioned to you that I would like you to explore about your forest fire situation in your countries. So the deadline is on the 21st of July. So you have, let's say, nearly 1 week, right, to to do this kind of assignment. Yeah. So this is the first what to say, first assignment for you. Someone may ask that how many pages that I should prepare for one assignment. So it depends on you. You can do within 5 or 10 page or even 100 page. It depends on you. Yeah. But please more very concise. I think between 5 to not more than 10 pages is acceptable, it's reasonable. So this is the first assignment. Anyway, I have the second assignment for you too. So the first assignment is for you to explore your fire situation in your countries. The second assignment will be focused mainly about the forest fire behavior and forest fuels in your country, in your specific ecosystem in the countries. So please take a look about your ecosystem in your country, and what about the forest fuel property in general of your country? What about forest fire behaviors in general in your country? And please select one specific ecosystem that you think that is very important and very close related to forest fire, and then bring it out in terms of behavior of fire, forest fuel, characteristic, etc. So that you can review your forest fire in your countries, right? Both statistics in the situation, cost of burning, etc., and the situation of your forested area in terms of forest fire. So please do it. And the second assignment, the deadline is until the 23rd of July. So our TA, teaching assistant, or his name is J, will contact you in detail through the chat and also through the email, so that you can prepare the assignment and send to him. No, sorry, not to him, to the Google form correctly. Yeah. Okay. So those are two assignments that. Oh, sorry, I didn't share, right? I didn't share anything, right? Jay, can you see my share slide?
Yes.
Just now, right?
Yeah.
Okay. Anyway, please send this assignment to the students so that they can see what the assignment is. So this is the first assignment. Oh, sorry for that. I just shared to you. Yeah, the first assignment is about the forest fire situation in your country. And the second assignment is what about the forest fuel and fire behavior in your country. Please select one specific ecosystem that you think that very related to forest fire. Okay, that's the my assignment. The next presentation that I would like to talk to you is about, now we going into a kind of management. I would like to talk to you a bit about the fuel management. Fuel management, okay. In terms of forest fire management, I think the most important things that most of the scientists, researchers, practitioners who take in charge in forest fire management that they can do is about fuel. Because within the three factors, right? Climate, topography, and fuel. Topography, we cannot do anything. Climate, we cannot do anything. What only thing that we can do is about the fuel. So that's why the fuel management is very important. So I would like to talk to you about the fuel management. As I said that the fuel is only one factor that the forester or the firefighters can manage. So at first you have to understand how to classify the forest fuels. So when managing the forest fire, the understanding of the type of fuel is very important. Normally, we can classify the forest fuel into three main categories: habitat, stratum, or time lapse. So there are many kinds of fuel classification. For the habitat classification, if we classify the forest fuel based on habitat or habit, so this will refer to the physical form or growth habit of vegetation, such as grasses, shrubs, or trees. So different fuel habits burn differently and influence fire behavior differently. For the fuel classification based on the stratum, so this classification consider the vertical layers where the forest fuel is located, either the ground fuel, the surface fuel, or ladder fuel, or the crown fuel. So each stratum contribute differently to fire spread and fire intensity, and of course, different in fire behavior. But if you classify the forest fuel based on the term that we call time lapse, what is the time lapse? The time lag refers to how quickly the fuel moisture content respond to the change in atmospheric conditions. So it refers to the rate at which that fuel gain or lose moisture, depending on the atmospheric condition like humidity and temperatures. Technically, time lag is defined as the time it takes for a fuel property to reach about 63% of the difference between its current moisture and environment equilibrium. So this process directly influences the fire ignition intensities and spread, because the drier fuel ignite more easily and burn more intensely. So understanding the time lapse help us to classify fuel into different time categories, such as 1 hour, 10 hours, or 1,000-hour fuel, and predicted how quickly they will respond to changing weather. This illustration will show you how the moisture content of dead fuel change over the time in a drying environment, assuming a constant temperature and atmospheric pressures. So we start at the initial moisture level on the left. As the time progresses, the fuel lost moisture and move toward a new equilibrium moisture content, which reflect the surrounding atmospheric humidities. The curve demonstrates an important concept. The rate of moisture loss is fast at the beginning, as you can see, but slow down as the fuel approach equilibrium. So this exponential pattern form the basis of the time lag classification. For example, 1-hour fuel reach about 63% of their moisture adjustment in 1 hour, while the 100-hour or 1,000-hour fuel take much longer. Therefore, the time lag classes are directly linked to the diameter of fuel properties. A 1-hour fuel fineness, which is less than 0.25 inch in diameter, like a needle and glasses. So this fine fuel dry out and ignite very quickly. In contrast to 10-hour, 100-hour, or 1,000-hour, which has different field diameter, as you can see from this slide. What is important for the time lapse? The short time lag fuel, like glasses and needle, dry out, ignite very quickly, as I mentioned earlier. So they play a major role in initial ignition and rapid spread of fire. In the other hand, the long time lag fuel, such as log and large branch, take longer to dry. But these fuel are the key to the sustained burning and smoldering phases of the fire, often contribute to prolonged fire activities. The fire danger rating system, like the National Fire Danger Rating System, or NFDRS. So this system uses the time lapse classes to estimate the fuel moisture content, which is a critical factor for predicting fire risk behaviors. So tomorrow, Dr. Wanthongchai will give you some idea about the fire danger rating system, how it works, how to do, how it works for the forest fire danger rating system, so that he can explain more about this for you. So wait for tomorrow. The time lag application. So understanding the time lag is essential for a variety of fire management practices. It plays a key role in prescribed burning planning, helping to determine whether fuel are dry enough to burn safely and effectively. The fire danger forecast, as I said, rely on time-lapse data to assess how likely fuel are to ignite under the current weather condition. Fuel moisture sampling often target different time-lapse classes to get a comprehensive picture of fire risk across a fuel type. The finally, the wildfire suppression tactics are guided by time-lapse knowledge. Knowing which fuel are likely to burn quickly or smolder help firefighters make informed decisions on the ground. So the time lag is a vital tool for both proactive and reactive fire management. The next, I would like to talk to you about the fuel management concepts. So this diagram you see now illustrates the core concept of fuel management. At the top, we see that the fuel treatment practices such as thinning, pruning, or prescribed burning, or even the mechanical removal. So those are field treatment practice. So these are all the methods that we use to alter the quantities, the structure or continuities of fuel in the landscape. So the goal of this treatment is to produce measurable impacts. The first, to reduce the intensities and spread of fire. The influence the influence of the effect of fire on ecosystem communities and infrastructure. To lower the cost of suppression by making fire easier and safer for the control. And ultimately, contribute to the fire hazard reduction, especially in a high-risk area near the human settlement or fire-prone ecosystem. So the fuel treatment objective, there are two objective for fuel treatment. The first one of the most primary goal for fuel treatment is to modify the fuel characteristic in the way that reduce the wildfire risk and enhance the fire control. So in this sense or in this objective, so we do many things to modify the fuel characteristic. For example, we modify the fuel type, whether it's a glass, sharps, or woody debris. So different fuel burn differently. So selecting or replacing the fuel type can change the fire behaviors. The second, if we modify the fuel loads refer to the total amount of combustible material. So reducing the heavy loads like the dead wood or leaf litter can lower fire intensities. We can modify the fuel arrangement by altering vertical and horizontal structures, such as thinning of understory or separating cowl layer that we can prevent fire. Changing the fuel continuities. So treatment like creating the fuel break or mosaics disrupt the spread of fire by breaking up a large continuous fuel bed. We can change the fuel ignition. So the managing of fire fuel and ignition source can reduce the likelihood that fire will start and spread. And also we can modify the combustion rate, because some treatment that aim to slow down how quickly fuel burn, giving the firefighter more time to respond. So those are the things that we modify and we change the forest fuel characteristic and then will impact to the forest fire behaviors. The second objective of the fuel treatment is to build up and maintain the fire-resistant forest. So in these cases, we begin by reducing the surface fuel, such as dry leaf, branch, and underbrush. So these are the first to ignite and drive fire spread along the ground. Next, we can increase the height between the ground and the base of the tree crown. This can be done through pruning and thinning of the ladder fuel, which prevent fire from climbing into the canopies. So all of the action contribute to the forest that is not only healthier, but also better able to withstand and recover from the wildfire. So those are two main objectives of the fuel treatment. So the fuel treatment or fuel management, normally we can do with three main things: reduction, isolation, or even conversion. So what is the reduction? What is the fuel reduction? The fuel reduction, this involve the lowering of fuel load through many practice like prescribed burning or fuel utilization, such as converting to biomass into energy or compost. Fuel isolation. So this strategy separate fuel source using the fire break or zoning and landscape management to slow down or stop the fire spread. The fuel conversion. So this includes the changing of vegetation type or structure, such as creating a wet fire break or using the ground cover and crops that are less flammable. So together, this approach helps to reduce the fire intensity, spread, and risk, especially in a fire-prone landscape. The effective of fuel management play a vital role in wildfire prevention and landscape resilience. It serves three main purposes. First, reduce the wildfire intensity. Second, protect the human life and asset. And third, support ecological balances to ensure that the fire remain a natural and beneficial part of the and for the ecosystem rather than destructive force. So now we go in more detail about the method for fuel management. The first one, as I said, that there are three main things that we can do with the fuel, right? Reduction, isolation, and conversion. Now we are talking about the fuel reduction. The fuel reduction is one of the most direct way to lower the wildfire risk. The goal is to remove or reduce the flammable materials. And there are several key methods. The first one, of course, the prescribed burning that we will talk later on next other days. Prescribed burning. So by intentionally set low intensity fire use under the control condition, we can reduce the fuel by use the mechanical thinning that involve removing all small trees or dense undergrowth using tools like chainsaw, brush cutter, or mowers. We also can reduce the fuel by biomass removal by collecting and transporting excessive vegetation off the site for use as compost, mulch, or even bioenergies. So when apply this carefully, this practice reduce the fire intensity and make it easier to control a wildfire when they occur. For the fuel conversion, the fuel conversion is a strategy that focus on replacing the flammable fuel with less flammable vegetation to reduce the fire risk. So this is especially effective in a wildland-urban interface where the home and community meet the flammable landscape. For example, we can replace the fire-prone grass with a green belt, irrigated crops, or fire-resistant shrubs to reduce the chance of ignition and slow the fire spread. So one common practice is establishing a wet fire break. It's the zone that plant with moisture loving or irrigated vegetation that can interrupt the fire movement. Importantly, the field conversion alters not just vegetation but the entire fire regime, because the fire regime and field structure are interconnected. That means any change in vegetation will affect how fire behave in the future, so both in frequency and intensity. So be careful on that. So fuel conversion is not only a preventive tool, but also the way to reshape a fire-prone ecosystem toward the greater resilience. So this is the second thing. What about the fuel isolation? The fuel isolation is the strategy used to interrupt the continuity of the fuel, which help to stop or slow the spread of wildfire. So this approach doesn't remove the fuel, but instead create a gap in the landscape to act as the barrier or fire, act as the barrier for fire movement. So the key tools for field isolation include break, field break, natural barriers. What is the fire break? The fire break is a clear strip of the land with no vegetation that stop the fire spread. But for the field break, the field break is the area where it reduce or modify the fuel, sometimes combined with roads and patrol paths. Natural barriers like a road, river, rocky outcrops that can serve as a boundary or barrier that fire cannot easily cross. So this is the kind of field isolation that we can do. In many countries, I know that most of the firefighters and fire manager, they prefer to create a fire break, right? Because it's more easier, and of course fire break can use both for breaking the fire and also can use as the route for transportation as well. So this photo just to show you how different between the fire break and the field break. Okay. What about the difference between fire break and field break? So the fire break is a tactical emergency use barrier stripped of all field, whereas the field break is a border planner the area with reduced field load. So the difference is showing in this slide, right? The very important thing is that the field break we modify, reduce, but not necessarily the bare land. But for fire break, most of the vegetation will be removed, left only the mineral soil. Now, this is very different between fire break and field break. And I would say that most of the field isolation in our country, in Thailand, mostly they do fire break. We are not so much familiar with a field break. Yeah, mostly we produce or we set up the fire break to protect the fire. But for the forest field management, sometimes we not only do in one what to say one point. For example, we not only do only for field isolation or field reduction, but also we combine both isolation, reduction, and conversion together. We call it integrated strategies. So this is an effective fuel management approach that doesn't rely on only single method. So it combines the multiple strategies for the greater impact. The first, we combine all three methods, as I said, reduction, conversion, and isolation to increase the overall effectiveness. For example, we can pair the fuel reduction with the fuel isolation to create a strategic buffer zone around the communities or protected area. The fuel conversion is important for long-term solution, such as replacing the flammable gases with the less flammable vegetation. Most importantly, all strategic should be tailored to the local context, considering the land use, topography, vegetation type, and the areas of fire regimes. So this integrated strategy ensures both short-term protection and long-term fire adapted landscape. So in many cases, they combine many many methods together, so that the fuel management can be more effective. The fuel modification strategy method. The fuel modification is essential to reduce the wildfire risk and improve the forest resilience. So what can we do for that? So we can do in many ways. For example, we can do with thinning, that we carefully select which tree to remove and determine the right spacing to reduce the crown fire risk. The timing is also very important for thinning, because if you thinning at the wrong time, it can increase the vulnerabilities. We can use pruning as for the field modification method. So we can do pruning, which less the height of the tree crown base to reduce the ladder field that allows surface fire to climb into the canopies. We also need a proper slash disposal and regular weeding to remove a fire field. Burning is also acceptable. The burning includes prescribed burning to help eliminate excess fuel in the controlled manners. And finally, a long-term success depends on land management practice and policy, ensuring that field treatment align with the local goal, regulation, and fire regime. The last slide, just to show, nearly last slide, sorry. This slide shows the tree before and after pruning. On the left, before pruning, the low branch are close to the ground, right? That acting as the ladder field, allowing the ground fire to climb into the canopy. The tree retain lower branch, which contribute to a lower center of gravity, meaning that its weight more even distribute close to the ground. This is the picture on the left-hand side. On your right-hand side, right after pruning, the lower branch are removed, while this reduce the ladder field and the fire risk. It also shifts the center of the gravity higher up the trees, as more mass remain in upper crown. So what I want to mention is that although the pruning helped to break the vertical fuel continuities and fire spread, it may slightly reduce the tree stabilities, especially under strong wind, which is important to consider when planning thinning and pruning operation. So please be careful. If you prune it too much, you will increase the center of the gravity higher, and that make tree more at risk for breaking down. The last slide for today. The last slide. So the last slide show you the cost and effectiveness of different fuel practice. So the fuel reduction method vary in effectiveness, cost, and practicalities. Here's a brief overview, right? Thinning reduce the ladder and crown fuel, but may increase the surface field unless the slab is managed, and it costs between 100 to 800 dollars per acre. This is from example from this. So just to show you the cost and effectiveness of different fuel treatment in the forest landscape. So if you have time, so please take a look at that and you see in more detail on that. So that's all the forest fuel management that I would like to mention to you for today. So that's all. And tomorrow, another guest speakers, Dr. Virachai Tanpipak, who has been working a long time with the forest fire detection, and he is the expert in remote sensing and GS technology that used for forest fire detection. So he will give a talk to you for 2 days about the forest fire detection using the remote sensing technology, and he may introduce to you the fire danger rating system, how it works, how to be done for that. So next tomorrow and to the day after tomorrow will be his turn. So please, because tomorrow will be very interesting things that I know that most of you are very interested in technologies, and using the remote sensing or GIS technology to detect the fire for fire management planning is very popular and very important nowadays, that we can save a lot of time for controlling the fire. Okay, that's the thing for tomorrow. And okay, that's all for today. And even tomorrow, I don't have any lecture to you, but I will stay with you because I would like to listen to hear what Dr. Vishai will talk about, because it's very interesting lecture. And remember, on Friday we have guest speakers from Australia, Dr. Richard Woods. He will give a talk on forest fire investigation, which is, I think, very interesting point for most of you and also for me, because you will see many techniques for fire investigation from him. Yeah. Okay, that's all for today. Have a good evening. And also don't remember for my two assignment that I just talked to you. Yeah. Okay. See you tomorrow. Bye bye.